All right, so 4.1, we're going to learn about quadratic functions. So this is a different type of graph and a different type of function that we could have. So we've done linear when we just have like an x, our graph is a line. When we've done absolute value, so when we have an x and absolute value, what does our graph look like for absolute value? Anybody remember the shape of an absolute value graph? The absolute value looks like a V. And now we're going to do quadratic functions. So quadratic functions are x squared, and our graph looks like a U. That U is called a parabola. So a parabola is the graph of a quadratic function. So it looks like this. So we see our quadratics in vertex formula. So vertex form is y is equal to a times x minus h squared plus k. Our axis of symmetry is a line that divides the parabola into two mirror images. So the equation of our axis of symmetry is x is equal to h. That is an h. So whatever our h is here, we always flip the sign of it, and that's our axis of symmetry. So it always repeats. So our axis of symmetry is a vertical line right down the middle of our parabola, and it cuts our graph into two equal parts. Now our vertex of our parabola is h comma k. So we get our h and k from our formula. And our vertex is the point down at the very bottom. So like it'll either be at the very top, so the top of the mountain, or the bottom of the mountain. Bottom of the valley, I guess. So that's our vertex. Our domain is always going to be all real numbers. So on a test or quiz, when it asks you what's the domain of a quadratic, the answer is always going to be all real numbers. And then our range, if it opens up, it's from whatever our k value is to infinity. And if it opens down, it's from negative infinity to whatever that k is. So this is our range. So the k repeats in the vertex and again in the range. So the graph of any quadratic function is a transformation of the graph of the parent quadratic function. And our parent quadratic function is just y is equal to x squared. So anything that happens to that x squared is just a transformation. So we've done transformations with our absolute value graphs where we added. If we add on the outside, we move up or down. If we add on the inside, we move left or right. So we're doing that same stuff again with quadratics. So we're bringing it back. Here, our vertex is at the very bottom here. So what would our point for our vertex be? 0, 0. And then our axis of symmetry is x is equal to whatever our x value in our vertex is. So what's our x value in our vertex? 0. So x is equal to 0 is our axis of symmetry. So again, here we have our vertex form. The a that's getting multiplied out front, if it's negative, we have a reflection. So just like we remembered before, we would have a reflection across the x-axis because it's outside. And then we could also have a vertical stretch or vertical compression. So if it's greater than 1, it's a vertical stretch. If it's less than 1, it's a compression. So we've done this before. This is just kind of a little review. H on the inside means that we're moving horizontally, so left or right. If we're adding, which direction do we go? Left. And if we're subtracting, right. And then when we're adding on the outside, it's a vertical translation, so we're going up or down. If we're adding, which way are we going? Up. And if we're subtracting? Down. And our vertex is whatever this H and K are. So we just repeat those numbers for our vertex. H, K. And then don't forget, we always have to change the sign of H. So when we put it in our vertex, we always change the sign. So here we have an example of a reflection, stretch, and compression. So if what we're multiplying out front, so let's say we had x squared, and then we were multiplying it by negative, let's just say negative 1. This would be a reflection. So a reflection just flips it upside down. When your A is negative, it makes it a sad face. Let's say we had y is equal to 2x squared. If that number out front is greater than 1, what do we have? A stretch. And then if y is equal to 1/2 times x squared. If it's less than 1 but greater than 0, what do we have? A compression. Next, we have an example of translation, so moving it up, down, or left or right. So our H inside moves it left or right. And then our K outside here, if we're adding it outside, that moves it up or down. And then whatever our H, K is, that's our vertex. So let's look at our first example. We have to identify the transformations. So what does this -2 on the inside do? It's our H, but we move it right to. Awesome. What about +4 on the outside? Awesome. Up 4. Now what would our vertex be? Perfect. 2, 4. Because we get it from this number inside and the number that's added outside. And we always flip the sign of our H. This is our H, this is our K. Now what's our axis of symmetry? It's always x equals whatever your x is here. So x equals 2. All right, here we have to identify our transformations. So what does this -4 on the inside do? Right 4. Do I have any other transformations? Nope, that's it. Let's identify our vertex. Remember, vertex is H, K. So what we're adding inside and what we're adding outside. So what would my vertex be? 4, 0. Awesome. And then what's my axis of symmetry? X equals 4. Don't forget that x equals. And it always repeats whatever your x is here. All right, in the next one, we have a few transformations going on. So this negative on the outside, what does that do? Reflection on the x-axis. All of these will always be a reflection on the x-axis. So you could say a reflection on the x-axis or just a reflection if you want. What does the 7 being multiplied on the outside do? Stretch. What about the -1 on the inside? Right 1. And then +1 on the outside? Up 1. All right, and then let's identify our vertex and axis of symmetry. So what would our vertex be here? 1, 1. Awesome. We get the number from the inside of the parentheses and the number adding outside. So this would be 1, 1. And then what's our axis of symmetry? X equals 1. So we just repeat our x, and you have to put the x equals. All right, the next 3, we actually have to graph it too, but we're doing the same stuff that we did before. So what's our vertex here?
1, 3.
Awesome, 1, 3. So our vertex is 1, 3. We can go ahead and graph that point. We're going which way first? To the right one, up 3. So 1, 3. Our axis of symmetry is what? X equals 1. And our axis of symmetry is always a dotted line that goes right down the middle of our vertex. For our graphs, we're either going to have a maximum or a minimum. So if it opens up, we have a minimum value because our vertex is at the lowest point. So if it opens up, we have a minimum. If it opens down, we have a maximum. And our A value determines if it opens up or down. So remember, our formula is y is equal to A times x minus h squared plus k. So we got our h and k for our vertex. And then our A is what's being multiplied out front. What's our A here? -2. So if it's negative, do you think it's going to open up or open down? It opens down. So think about it. If it's positive, you're happy, it's a smiley face. If it opens down, you're sad, it's a frowny face. So will I have a maximum or minimum here? A maximum. So I'm going to cross out minimum. We don't have one.
We only have one.
You'll only have one. You can't have a max and a min. So you'll either have one or the other. And our maximum value is always your y value in your vertex. So our maximum is just 3. Same thing. It's always the y value in your vertex. What did we say our domain is always? All real numbers. You could say all real numbers, or you could say this R with like 2 lines through it. That means all real numbers. Or if you want, you could say ARN, all real numbers.
So the domain is always going to be all real numbers.
Always all real numbers. That's like a freebie on your test. Domain is always all real numbers. And then our range. We said it opens down. So is our graph going to go up to positive infinity or down to negative infinity? Down to negative infinity. And then what's our y value where our graph stops? Yeah, it's our k. And what's our k? 3. So whenever you use infinity, you put the parentheses, but whenever you do the number, you put a bracket. And then we have to finish graphing. So I have 1 point on my graph. How do you think I can find another point? I'm going to find another point just by plugging in a number for x and solving it for y. So we've done that before. We're going to plug in a number for x and solve for y. I have negative 2 times x minus 1 squared plus 3. What do you think a good number to plug in for x is? I could plug in 1 because 1 would be not too much math to do, but in my vertex my x is 1. So technically we already know what we'll get when we plug in 1. We'll get 3. So what's another number I could plug in? 2 would work. What do you think might be like an easier number to plug in? 0. 0 works. You want to plug in something close to your axis of symmetry. So I'll make a little note here. Plug in a number close to the axis of symmetry. So we're going to plug in 0. So I have negative 2 times 0 minus 1 squared plus 3. So what do I have to do first here when solving? Parentheses. So negative 2 times, what's 0 minus 1? Negative 1 squared plus 3. So I did parentheses. What do I have to do next? The exponent. So what's negative 1 squared? Negative 1 times negative 1. Positive 1. So I did the exponent. What do I have to do next? Multiplication. What's negative 2 times 1? Negative 2. Do I have any division? Nope. So then last I add. What's negative 2 plus 3? 1. So what did I plug in for x here? I plugged in 0 and got 1. So I'm going to put this point on my graph. I'm going to stay on 0, go up 1. Looking at our graph here, the axis of symmetry is like a mirror. Whatever you have on the left side, you're going to have the same thing on the right side. So if I have this point that is one space away from my axis of symmetry on the left side, I'm going to have the same exact thing one space away from my axis of symmetry on the right side. So there's my other point. All you need for these graphs are 3 points, and then you can draw your parabola. So my parabola is going to look like this. It's not very pretty, but there we go. All right, so the next one. First thing we want to do is find our vertex. What's our vertex going to be? Negative 3 comma negative 4, because remember, you always have to change the sign of your h. So negative 3 comma negative 4. What's my axis of symmetry? X equals negative 3. So let's plot those two things on our graph. I'm going to go to the left to negative 3 and down 4. Then I'm going to put my axis of symmetry right through it. Max or min is determined if our graph opens up or down. What do you think here? Does my graph open up or open down? It opens up because I don't have a negative being multiplied out front. So it opens up. When it opens up, do I have a maximum at the vertex or a minimum at the vertex? A minimum. So I'm going to cross out maximum. What is my minimum value? Awesome, negative 4. It's the same thing as the y. What's my domain? All real numbers. So I'm going to put the little r for all real numbers. And then my range, does it go up to positive infinity or down to negative infinity? It goes up to positive infinity. So where is it going to start? What's the smallest value my graph has? Negative 4. So it always, again, repeats the y value here. So negative 4 and goes to what? To infinity. So when writing the range, you start with the smallest number and go to the biggest. So if it went down to negative infinity, you start with negative infinity first. Am I done? What else do I need? I need to plug in 2 more points, or I need 2 more points. So what can I plug in here?
0.
I could plug in 0. You want to plug in something close to your axis of symmetry, but 0 would be fine here too. So I have 0 plus 3 squared minus 4. So I plugged in 0, I'm going to get some number for y. What do I need to do first? Remember, PEMDAS, parentheses. So 0 plus 3 would just be 3. So I have 3 squared minus 4. What do I do next? Exponents. What's 3 squared? 9. So 3 times 3 is 9. And then what should I do last? 9 minus 4, which is 5. So I plugged in 0 and got 5. So I'm going to stay on 0 and go up to 5. So I have a point all the way up here. Okay, so I have a point that is 3 spaces away from my axis of symmetry on the right side. So I need that same point that is 3 spaces away on the left side. And then just connect your dots with your U. So there's my graph. Do you guys have any questions? So if you see here, we have -3. It gets repeated again in your axis of symmetry, -3. And then the y, we have -4, which gets repeated again in the max or min, and it gets repeated again in the range. And those are the only numbers that you have there. So all your numbers are going to repeat. All right, first thing we want to do is identify our vertex. Kayla, what's our vertex? Awesome. So you always change the sign of your h, so it would be -7, -8. So let's put that on our graph. We're going to go to the left, -7, and down 8, which is kind of off our graph, but it's fine. Right there. What's my axis of symmetry going to be, Lucas?
3.
X is equal.
X and 3.
What's my x here?
Oh, -7.
-7. So x is equal to -7. It's always going to be a dotted line right down the middle of your vertex. Does my graph open up or open down here? It opens down because it has a negative out front. So it opens down. So is my vertex at the maximum or minimum? It's at the maximum. So I'm going to cross out minimum because I don't have one. What is my maximum value? Awesome. It always comes from the y in your vertex. So it'll be -8. Nicole, what's my domain? All real numbers. It is always all real numbers. And then what's my range? If my graph opens down, am I going to positive infinity or negative infinity? Negative infinity. So negative infinity is going to be the smallest number. So that's where I start. I always start with the smallest. And then what's my highest y value? -8. You always repeat the same number in your vertex, that y. And then, what else should I do? Plug in a number. What number should I plug in here? I can plug in 0, but I don't really want to here because it'll give me like a really, really big number. Remember, you want to plug in something close to your axis of symmetry. What's my axis of symmetry? -7. So what's a number close to -7? -6. Let's plug in -6. So I have -3 times x is -6 plus 7 squared minus 8. So I'm plugging in -6. I'm going to get some other number for y. What should I do first? Parentheses. Remember PEMDAS. Parentheses. What's -6 plus 7? 1. What should I do next? What should I do next? Exponent. What is 1 to the second power? 1. So 3 times 1 minus 8. Next, I'm going to do multiplication. What's -3 times 1? -3. And then what's -3 minus 8? -11. Yes. So again, this is off my graph, but I'm still going to put it here anyway. So -6, and then I'm going to go down to -11. So right there. So since this is one space away on the right side of my axis of symmetry, I need the same thing one space away from my left side. And then once you have your 3 dots, you can just connect your dots.